jointly with the Woodrow Wilson Center. And basically, the whole idea behind this seminar is to think about problems of large scale and solutions at large scale. Because if we are to manage our planet, we definitely need to be addressing those things at scale. So I'm not going to take up any more time because we have a really fascinating program. And I will invite my colleague, Paul Schopf, from George Mason to take it from here.
Thank you, Tom. So today we're going to look at the state and fate of the Arctic. There's been so much climate change going on in what's happening in the Arctic, and so we thought we'd pull together some experts and look at various features of the Arctic climate change. And our first speaker is going to be Admiral Dave Titley, retired, and he's going to discuss kind of the situation with the opening Arctic, everything from national security issues to what's happening up there with the sea ice change and other climate changes in the Arctic. Then we have Dr. Igor Krupnik from the Smithsonian Institution, anthropology, looking at what this change really means for the peoples that live there. And, it's not an uninhabited place. There are peoples, and they're affected by this in strange ways that I'm not able to comprehend. And then finally, we're going to have Dr. Miriam Jones from the U.S. Geological Survey looking at how climate change has a number of feedbacks and possibilities for amplification. I asked her to talk about the possibility of methane hydrate bombs and things, which has been in the press lately, but we'll get the real scoop from her on what's going on with that. So without further ado, I would, we generally in these sessions, we don't give long introductions of the speakers outside. It's a flyer with their bios, which, if you want to follow along on that, you can catch up with their backgrounds and things. So without further ado, I'd like to have David Titley come up and give us the opening talk. Great. We'll be doing 3 20-minute talks and then have a panel for questions for after that.
All right. Okay. Well, thanks very much. No, I'm not playing with my phone while I'm talking. That would probably be the height of rudeness. But I've found that there's no clock in here. And if there's no clock in here, it's really unfair to the other two presenters if I use like 58 and a half of the 60 minutes. So I'm not going to do that. We'll use 20 minutes. I'd like to thank both George Mason and the Woodrow Wilson Center for inviting me down here today and the opportunity to just kind of talk a little bit about the Arctic. I'm going to concentrate on national security, but hopefully I'll be able to put this in some type of context here. Are we recording this? So if I step away from the mic, is that really screwing things up? Yes. Yes. Okay. So I am chained to the microphone. And I do a really poor job of that. So we'll try. Okay. So before I talk about the Arctic, though, I'm just going to talk 1 or 2 slides about climate change. And for those of you who have seen the talk, I apologize. I was telling Caitlin down here in the front row, she could probably give the talk at least as good, maybe better than I can. But if you notice, I do not have a picture of the poor, lonely polar bear up here. Because if you just Google climate change and then hit images and just kind of count them, and since I have no life, I actually did this one Sunday. There's a lot of images. Almost a third are like some sort of polar bear-like kind of, the polar bear on the iceberg. Well, you know what that does? That says to a lot of people, this is an environmental issue. You know how many people care about environmental issues? Now here, probably a lot. But when you go out to the public in general, so it's not an environmental issue, in my view. It is, of course, but it's bigger than that. It's a lot bigger than that. It's a people issue. It's about you, your families, your sons, your daughters, your moms, your dads, your neighbors, the people in your village, in your town, in your city, in our country. It's really about people. It's not polar bears or polar bear plunges. This is, and Miriam, I'm sure, knows where this comes from because it's actually, at least I get this out of the USGS, but U.S. Geological Survey. This sort of dot here is really all the fresh water, or excuse me, all the water in the world. The two dots that you can't see are the fresh water in the world. And the reason I have that up is if you think about climate change, there's so many multi-facets to it. It can just make your head hurt. It can make your head hurt if this is what you do as a day job. And if you're like just trying to pay your mortgage and, and take care of your regular job, it's really, really hard to, get your head around it. So if you can remember, it's about water. That's really what it's about. Too much, too little, wrong place, wrong time. It's wet where you thought it was going to be dry, dry where you thought it was going to be wet, salty where you thought it was going to be fresh, liquid where you thought it was going to be solid, and that's what we're going to talk about a lot here this afternoon, more acidic where you thought it was going to be neutral or even basic. If you think about water, that really encompasses an awful lot about climate change. And then the third part is, who's this guy here on the right? Can you see that? I know we got the arc lights, the xenon arc lights on the screen here, but that's Carville. So what did he famously say about the economy? It's the economy stupid, right? We're in DC. Everybody should know this stuff. This is what you guys live on. So, I would argue that climate change, it's not so much about the climate, it's about the change. Because if you think about it, there ain't nothing really wonderful and optimal about the climate we have. It's frickin' 33 degrees when I came down this morning in fog and drizzle. Is that wonderful? No, it's March. I mean, I'm looking for daffodils and stuff like that. There weren't any. But what we have had for human civilization is stability. So it's kind of rained at about the same time. We could grow crops where we wanted to. We could build our cities where we wanted to because the water didn't appreciably go up or down. We had stability. And now, not only are we changing it, but if you read last week or yesterday's AAAS, American Association of Advancement for Science, What We Know report, a bunch of really smart people are saying not only are we changing this, we're probably changing climate at a rate faster than millions, perhaps tens of millions of years. So we're like kind of on this big, big escalator. And the question is, and it relates to the fundamental national security question, is are we going to change the climate faster than we can adapt to it? Because if that happens, now you got a security issue because people don't deal well when they can't adapt to their physical environment as fast as it's changing. The ecosystems don't, the animals don't, the plants don't, the ocean doesn't, and people don't. And that's kind of the crux. Okay, I talk about climate, and we're all here to talk about climate, but whenever it's climate or Arctic or a component of climate, remember it's in the context of a population that is now 6-7+ billion people and still going up. It's in a competition, all those 6 and 7 billion people, they want energy. They need energy. They need fresh water. They need food. It's not just wanting. We need that. We need that to live. We are globalized. We are connected, whether we want to be or not. In different talks, I can go down through that, but I think everybody here probably understands that. We are in a technologically advanced world. This is Moore's Law, and it keeps on marching along. So not only are we connected, we all kind of know how each other is doing. And then who are these fine gentlemen here? The European finance ministers. And why do I have them up here? Because we all tell ourselves we're out of money. So we're going to deal with all of this stuff, including climate change, and we say we're out of money. So I'm not going to talk about all these other things, but I would just ask that you sort of remember that when we talk about climate change, it's one of these big, big components of the 21st century that's going to impact all of us here. Okay, I'm kind of stepping down here to now the U.S. Department of Defense, and this is the titly unauthorized version of how I see the Department of Defense think about climate change. And there are sort of 4 tribes or fiefdoms, whatever you want to call them, 3 of which admit they do climate, and 1 which does climate, but they don't really want to talk about it that way. The Arctic guys and gals, they think about the Arctic, and that's what we're going to talk about. There's a whole nother set of people who think about infrastructure, bases, training ranges, what's sea level rise going to do to that, if it gets too hot, if it gets too dry, if all the endangered species move to my range because it's like protected, what am I going to do? There's a security aspect. There's things like how climate change has impacted, and there's a bunch of smart people who have written about this, like impacted the Arab Spring, impacted the current conflict in Syria. So a lot of times people think, oh, security, that means the United States military is going to have to do more what we call humanitarian assistance and disaster relief. My view on that is we will be lucky if that's all we do. I think what we're going to see is like varsity level conflicts, probably unpredictable until they come up. Will they be caused by climate change? It's never that simple. But climate can certainly be a component of this, and we'll wish we were only doing humanitarian assistance and disaster relief. And then finally, the energy guys, especially in the Navy, are doing some great things, but they just do not want to be talked about as climate because they already have a hard enough time getting the program through our friends and colleagues in the House of Representatives, and if it gets tied to climate, they see it going the way NOAA Climate Services did, which was basically a near-death experience for that agency. And the Navy's not looking to live a near-death experience. Okay, so I only can remember 3 things at one time. So here's my 3 things about the Arctic. It's an ocean. It's primarily an ocean environment. It is changing faster than any place else in the world physically. And it's not a vacuum. And it's not a vacuum both physically, and maybe Miriam's going to talk a little bit about how impacts of climate in the Arctic affect us. But it's also true politically. What happens in the Arctic does not stay in the Arctic. And conversely, when relationships go up and down in the middle latitudes, that can be affected as how it plays out in the Arctic. So what's this here? Anybody know? You guys know. Bering Strait, right. You're in the elite 10% of the Americans that know there's the Bering Strait here. So in the Bering Strait, what are these islands? Exactly, because Caitlin's heard this about 5 times. So you have Big Diomede Island and Little Diomede Island. And who owns this one? Russia, right? Who owns Little Diomede? It's the U.S. So on a clear day, you can, in fact, stand on Alaska and see Russia. Just to let you know, you can do that. Okay, I'll show a couple of graphs. This one happens to come from my friends, the Brits. Anomaly, fancy way of saying difference. What they did is they took the average temperatures in the Arctic at every reporting station. So this isn't like, let me find one that like went up a lot or didn't go up at all. Every reporting station north of 60 degrees north for about as much data as we could find for over a century here. Take the 30 years between 1981 and 2010 and call that 0, call that average. You could take any number, but it doesn't matter. And then say, hey, where were we relative to that long-term average? So the black squiggly lines are the year to year. Lots of variability, lots of variation. The blue line is kind of like, okay, there's the trend. So if you do the arithmetic, and this is degrees Celsius, so if you do the arithmetic, you see that's like somewhere between 3.5 and 4 degrees Fahrenheit change in a century. That's huge. That's what we've already seen. And you can see that you would argue that maybe the rate of change since the 60s or 70s has really increased, but just even going back all the way. So there's a lot of change, and that's happening. Don't like that? Look at when the snow melts out of, this is Barrow, Alaska. This is from NOAA. This isn't quite as long. It starts at about World War I. Again, lots of variation year to year. We saw that on the last chart, and you can see these coming down. This is Julian date. So just for orientation, what you first see is the snow melts way, way, way too late in Barrow, because that's June 1st, and that's July 1st. That's, to me, too late. But you can see how it started like in the middle of June, and now it's getting to early June. And there's a definite trend. So we can look at lots and lots of different data. I'll show you this one. Some people have seen this. I showed this at a Chicago conference about a month ago, and then it seemed to get picked up in some blogs, but that's good. This, again, comes from my friends at NOAA, and it's basically, this is not a computer projection. It's not any kind of, well, maybe this is happening, maybe not. This is just observations. This was observations from microwave imagery, from satellites. They can see through the clouds, and they can also tell you how thick the ice is, and that tells you how old it is. White ice here is really thick, lots of white ice. This is 1995, 96, lots of white ice, thick multi-year ice. The blue is like the 1 year or 2 year old stuff. Now watch what happens when we get to 2007. So this is 02, 2003, 4, 5, 6, watch 07. Boom. Now it tries to sort of come back 09, 10, not much, 11, 12. And you just see that what's left is really just filaments of multi-year ice. So most of the ocean, when it freezes up, is now only 1 or 2 years old, whereas it used to be a lot of old, thick, hard ice. I mean, ladies and gents, that's just a massive change on about a decade scale that even 5 or 10 years ago, people thought would take decades and decades, if not centuries, to accomplish. So when we say the Arctic is changing faster than any place else, I hope I've shown you a couple things to go through that. Okay, so what does that do? This actually comes out of the US Navy's new Arctic roadmap that they released, I think, about 3 or 4 weeks ago now. So you kind of have a couple traditional trade routes. The one that goes along, this is Russia, right here, goes along the what they call the Northern Sea Route, or some people call it the Northeast Passage. This is the much fabled Northwest Passage. There are routes through here. I can tell you this is one of the last places the ice will leave. It's also pretty shallow in places through here, and it's just a tricky navigation detail. So what does all that kind of stuff mean? It means that I wouldn't expect a whole lot of commercial traffic to ever be using the Northwest Passage. And this is a route that doesn't really exist right now, but many people, myself included, think it will pretty soon. It's sort of that over-the-top route. It's like, why go along Russia when you can just cut the corner and go over the top? And over time, we think this will open up more and more in the late summer and early fall. So this, again, came out of the Navy. This is what they're thinking about. And let's see if we can see this. And again, I apologize for the lights here, but you're going to see a ship, if this works. Here we go. Please play. Well, there we go. Okay, okay, it's not going to play for whatever reason. So tell you what, we're going to skip it. What I was going to show you is there was actually a ship, the Nordic Orion, that last year went through both the Northeast Passage, or the one along Russia, and the Northwest Passage in the same year. We hadn't seen that before as a commercial ship. So that's what's going on. Okay, the DoD, they released, the U.S. Department of Defense released an Arctic strategy. And it looks actually remarkably a lot like what the U.S. Navy had released about 3 years earlier. But this is good. So this is, your boss basically saying, yeah, we kind of liked what you did. And this secure and stable region is actually almost word for word signed out from the U.S. Navy's Arctic Strategic Objectives that was signed out in 2010. So we're kind of, it's moving with bureaucratic speed, but we're getting the bureaucracy on board with saying, okay, we at least have the Arctic, and we need to kind of have a strategy as to what to do up there. There we go. There's an implementation plan. If you're in the federal government, you've probably seen that. The U.S. Navy, for example, and the Department of Defense is responsible actually for the ice modeling. Department of Energy is responsible for climate modeling. NOAA is responsible for charting up there. But it's sort of like one step below a strategy, where the president is basically, kind of finger in the chest. It's like, who's going to do what? So this came out, I believe it was on the 30th of January, if I'm not mistaken, and that's actually very encouraging. Okay, some of the Arctic considerations. We talk about the ice melting. It's still really tough place to operate. Who in here has been up to the Arctic? Okay, probably a third, a quarter. If you've gone in the summer, you just see that there's not a whole lot of other stuff up there. If you go in the winter, you kind of wonder, at least I kind of wondered, like, what in God's name am I doing up here? Because it's really isolated. It's hard to work in there. The more I was up there, the more I was in wonder and awe of both the people who have lived up there for thousands of years and even the European explorers who came up there in the 19th and early 20th centuries. I would have been one of those guys with, a few stones over my grave because I don't think I would have made it very, very far. It will continue to be harsh for a long time. There is very little infrastructure up there. We don't know everything that's on the bottom. The transportation, we've kind of talked about that. And there's some security concerns, generally overblown, but there's also the Allied perspective. The Japanese have asked me, well, if the Americans go to the Arctic, who will be in the Pacific? That's sort of an interesting question, but that's how some other countries have thought about this. This slide I stole from Caitlin several years ago, but it's sort of interesting. We sometimes look at what the Russians are doing along their north coast, and some people say, oh my God, it's the Russians. Well, now maybe we have a better reason to say, oh my God, it's the Russians. I don't know. But if you stand at the North Pole and look southward to Russia, their coast in many ways looks like the U.S. Gulf of Mexico, but on steroids. 3 rivers, each the size and scope of the Mississippi, fossil fuels, minerals, all kinds of stuff. Look at the development we have done on our Gulf Coast. It is, in fact, rational for the Russians to want to develop that. And they also have 50% of the Arctic coast there. Navy strategic objectives, we've kind of gone through these. Safe, stable, and secure Arctic is really what we're looking for. There are now, I'm very happy to say, 2 roadmaps. There's the one we did in October of 2009. And as I mentioned, about 2 or 3 weeks ago, it got updated, signed out by Admiral Jonathan Greenert, the current Chief of Naval Operations. And I'll show you a couple slides that came out of that. So this came out of the first one. And we pretty much were able to do much of this. This comes out of the second one. And I think the slides, if anybody wants these slides, either send me a note or I think do people can pick up the slides? Okay, I'm told people can pick up the slides. Or you can just Google Navy Arctic Roadmap 2014 and you can see this. But this is basically what the Navy is planning for how many weeks of ice-free conditions. So the blue here is ice-free conditions, shoulder season, some ice, and then red is pretty much frozen over. And if you look at that compared to what the Navy had put out in 2009, basically the Navy has moved their projections of ice-free Arctic to the left, or up, about 5 or 6 years. I mean, that's kind of, we did it in slightly different formats, but that's basically what it's saying there. There's an implementation plan, and then there's an implementation plan under this. It gets down to bureaucratic codes, but again, if you work in the federal government, you know that unless somebody's responsible, nobody's responsible. And if you've ever met Admiral John Greenert, he's a nuke, and what does that mean? That means that somebody's going to be responsible. So that's all good, because that means there's a reasonable chance that a bunch of this stuff is actually going to get done. It wasn't just the Navy looking at this. The Navy actually asked the National Academies to take a look at what's going on in the Arctic, and you can read their top-line recommendations here. One thing that Dr. Shukla has been incredibly helpful at supporting, amongst others, is something we call Earth System Prediction Capability. Because one of the things you realize is that unless you get better forecasting the Arctic and observing the Arctic, you're probably going to have a tough time ever operating up there. So as part of that, we're looking to how do we actually recapitalize all of the U.S. models and do it as a national effort, not as 6 or 7 or 8 agency efforts, which is kind of where we are today there. I'm happy to talk more about that with anybody in Q&A if you're interested there. There's unexplored contingencies. This is the flag of Greenland. It's interesting to do as a thought experiment when Greenland goes independent and China's been up there a lot. What are they going to do? Who are they going to like? Who are they going to come to for security? How's that all going to play out? Singapore and Korea, really, really interested in the Arctic. I think, this is one I'd almost pay money to watch on the sidelines. I think watching Russia and China in the Arctic is going to be pretty pretty interesting there. And the Finns are putting R&D money into actually building commercial vessels that can go unescorted through first-year ice. They think there's money to be made there. Some other companies think they're crazy. We'll see how this one plays out there. And finally, I've talked a lot about kind of bureaucracy and all that stuff, but I'll tell you that ultimately it's true in the Department of Defense, it's true in the Navy, it's true in really anywhere in our federal government. None of this stuff happens. You don't change a vector without leadership. Admiral Locklear, Admiral Greenert, Roughhead, Stavridis, all of those gentlemen have shown leadership on this issue, when sometimes the easy thing to do is just like hope it goes away and somebody else can deal with it there. So, if you want to know why the Navy is where it is today, it's really these gents here have had an awful lot to do with it. And I'll wrap up there, and I guess we'll take questions at the end. Is that right? Okay, thanks very much.
Thank you, David. And so now I'll invite Igor to come up and give us a slightly different view of the situation up there.
I hope I'm doing something right. Probably not. Here it is, yeah. I found myself. Can we go full screen? Okay.
Down a little bit.
Perfect. So it's hard to speak after David, but we're going to change the scale and change the subject. And the first slide that you can see, hopefully, is just one of the places that he showed on one of his slides. This is Bering Strait. And this is taken from the village of Wales, from where you can see, indeed, across the Bering Strait, you can see Russia. And I'll be talking about people who live in this area and with whom I've been working for the past 30-some years, so that I'll tell you the story of how we learned from them what's happening and how their views of what's happening up in the north differs from ours. When we did first learn about climate change in the Arctic, we actually have at least 20-year history of knowing that the Arctic is changing and studying it very hard. I mean, I'm talking about contemporary change in Arctic ecosystem. And Arctic people, of course, are not the first to experience climate change in human history, but today they are probably the best known and the most recognized actors in the history, in the story of today's global warming. So back in the 1990s, we already knew, including from them, that Arctic has been changing. We knew it even since the first IPCC report in 1990. And even then, we started kind of collecting data on various aspects of this change. Back by the year 2000, we knew already that Arctic climate change has particular impacts on northern communities, including increased coastal erosion, thawing permafrost, warming weather, advances in shrub vegetation, change in species distribution, and reduced access to subsistence resources. So this is not new. And I want you to know that we used to know about these things 15 or 18 years ago. And even then, the Arctic was called canary in the coal mine. So here is one picture of the polar bear that, that David just mocked. But some of the pictures, I took them from the reports that were published in the 1990s. So just imagine that for 20 years, almost 20 years, we knew what is going to happen, or actually what was happening. So at a certain point, probably about 2000, or early decade, we knew that the Arctic is close to the tipping point. And the very important idea of Arctic amplification, of things that are being increasingly felt at the higher latitudes compared to what is happening at the lower latitudes, have already been known. I put the covers of the Arctic Climate Impact Assessment Report of 2004 and 2005. The 2005 was a thick volume of about 1,000 pages, and it was 5 years in the making, and it documented almost everything that was known by that time about climate change. And it had a chapter on indigenous knowledge about climate change, in which I was one of the co-authors. What was interesting is that when we started Arctic Climate Impact Assessment in about 2000, the chapter called Indigenous Perspectives was on the table of contents number 14 out of 15. When we ended in 2005, it was number 3. So somehow miraculously, in 5 years of preparing this report, the value and the importance of what indigenous people in the North see and talk about the climate change kind of changed dramatically through this process. This is my slide. Also, I worked for the past 15 years with people in the Arctic trying to document what they know or knew about climate change. And very quickly, what I learned from them is they don't see a lot of warming. They call it in a different way. It's not cold enough. It's not cold enough in the ecosystem now to produce the conditions with which they are familiar and to which they are accustomed. And it's very important because to us, Arctic climate change is all about summer. To them, it's all about winter. It's winter that is so different today than it used to be. And to us, it is all about summer. It's about melting, about disappearing ice, about melting permafrost, about navigation, birds coming early, polar bears drowning. It's all summer phenomena. To them, the important part is what's happening to the land and water and ice in winter. So, if I may close that. Yes. So at a certain point, we realized that these people are not only canary in the coal mine, but they are partners in knowledge, in the knowledge of climate change. And the first publication on indigenous knowledge and on indigenous observation of climate change was done in 1997. Again, I urge you to think that for almost 2 decades, we already had partners in knowledge and an abundant source of information on which we could rely. What we learned from early studies, an early partnership with indigenous people, is that they have been recording a consistent signal of change. And that consistent signal of change is about unpredictability of what is happening, of increased volatility of climate and ice regimes, and of the situation when their traditional knowledge and practices that they kind of developed for generations were not working anymore. So that was indeed a very traumatic thing for them, which they try to explain in the title of that book that we published in 2002, The Earth is Faster Now. The Earth is faster to them, as if something is happening with such a speed that they have never seen before. And the only explanation is that somehow our planet is becoming much faster than it used to be. Here are the books that have been produced so far. So I want you to know that it is indeed a huge pool of knowledge. Now, people often ask, why do we need it? And how we can match it with data and observations that we receive from scientists. Well, the first thing is that there are many eyes, many more eyes than we have. And as I put it here, a small northern community, that's the village of Gamble, population 600. A small northern community can easily beat a good university by the number of experienced people it puts on weather, ice, and wildlife watch, 24/7, year after year, watching and monitoring their own land and their own sea. So this is a tremendous resource of very skilled, very well-qualified observers that so far we are either ignoring or underusing. Here are the faces of those people with whom we worked. And collectively, they have decades of experience of watching the Arctic at different places and recording how things are changing in their environment. And that's how they view it. They view it with with a very high resolution at local scale. They use traditional terms. They use traditional perspectives. This is a photograph of the ice of the village of Wales as recorded and with the names of the ice forms reported by that man. I don't know whether I can use this. Yes, by that man named Winton Wiyapuk, my partner in preparing this material. And as you can see, every piece of this ice scape is mapped, named, tagged, and known. So this is something that we still have to learn how to do. They work as teams. They share data. They always consult with elders and other experts. They reach out to other people, and they always share their knowledge. There is a saying that if you're stingy with your knowledge, it will rot your mouth. And that's how they live. Now, with the support of scientists and some money that we received through science projects, we are putting these observations, we're assisting them with modern technologies, with electronic atlases, with lots of computer stuff, with GPS and other ways of recording the change. So we are dealing actually with highly technologically advanced citizen science, and I hope and I wish that this trend will continue. But we have to look at Arctic people in many ways, and not necessarily, and certainly not only as canary in the coal mines, and certainly not as the source of knowledge. They're also fellow citizens at risk. And there are many more fellow citizens and at higher risk than ever before because of the melting Arctic. This is Barrow, Alaska, the largest northernmost community of 4,500 people, and look how flat it is. And look how vulnerable this place is to any major catastrophic storm that can come now any day or any year. We now have the double dip of climate warming. This is the community of Kivalina in 1961, and this is the same community in the main mid-2000 to 2005, 2006. You can see how much more vulnerable this place is now because it's 5 times larger. It has a very different infrastructure now, and if people here were ever affected by flood or by anything else, they could easily move. Just take this stuff and move. You cannot move this place, or if you can, you have to pay dearly for that. The recent study of the Army Corps of Engineers reports that 178 rural Alaskan communities are facing erosion problems due to heavy storms, permafrost thawing, and seasonal floods. I showed you in one of my earlier slides the hanging house in the village of Shishmarev. This is something that everybody knows. You know, maybe the second most popular image on Google after a polar bear on the shrinking ice would be the village of Shishmarev. So, and that's why I didn't put one here, but it will be on the next slide. But there are many more. There are many more villages. I was in Shishmarev in 1991. It was already eroding. It was already kind of considering relocation. It was already a dangerous place to live. But there, look how many of them are now. 178. And of this is Shishmarev. And this is Shishmarev as well. This is Kivalina. And of this, 26 are already sandbagged almost year-round, because you cannot take your sandbag protection belt. And they have already explored or already decided to relocate to higher ground at enormous estimated cost. And the cost is probably like, for a population of 300 to 400, a cost is $100 million per community. So in order to relocate 26 native communities that are under threat, this is the amount of investments or expenses that nobody could predict even a few years ago, even a decade ago. What I'm saying is the Arctic has many different faces. You know, the changing Arctic, the climate change in the Arctic has many different faces. Some of them are indeed exotic, and some of them are, you know, kind of journalistically exciting, polar bear on the ice. Some of them are just down-to-earth life every day in a community that is prone to flooding, and that may happen any moment during at least the time when there is no ice, and there's now much longer time when there is no ice. And that was back in, what's the difference is that in the 1990s, that was still very far away. I feel that situation has changed, or at least I hope the situation has changed, since the message was brought much closer to home after the Hurricane Sandy, and after a much larger area and much closer to where we live was threatened by the very same conditions that people in the Arctic face almost daily. So I suggest that the sooner we stop exoticizing the Arctic and its people and the problems they face, the sooner we kind of turn from the image of polar bear. Here I'm completely on the same page with David. The sooner we turn from the image of polar bear on shrinking ice and think of, as I call it, fellow citizens at risk, the sooner we become really prepared for what the Arctic faces, our people of the Arctic face, and how this message can and will be brought closer to home. And this is my last illustration. Arctic warming, it's everybody's bell. And here is again the polar bear and the famous chart. And I put it not at the hockey stick like everybody is accustomed to. This is also a very familiar graph, how the ice is shrinking. And the shrinking ice is the planetary belt. The shrinking Arctic ice is the planetary belt. And in this situation, people of the Arctic and the knowledge and their experience matters as much, and if not more, than any of us could contribute, because we're all together in this boat of climate change, and everybody's contribution matters. Thank you.
Thank you, Igor. And now we'll ask Dr. Jones to fill us in on what's happening up there with feedbacks and climate change.
Hi, so I'm going to be addressing Arctic climate change feedback. So I'm going to focus mostly on the carbon cycle because I think the carbon cycle is something that impacts all of us in terms of the atmospheric feedbacks to warming. And I'm also I was asked to address the methane ticking time bomb, so I'll go into that a little bit too. So it's been addressed already that the Arctic is warming, so here's an image showing Arctic warming anomalies over the last 10 years, roughly. And you can see there's like almost a 10-degree temperature excursion over most of the Arctic Ocean. And this has been shown a couple times before, but you can see the Arctic sea ice is declining, and to the right is just a still image of the animation we saw earlier that shows that the Arctic sea pack is becoming thinner. All of the older, thicker sea ice is disappearing. Oh, here's a pointer. So this is the most recent image here, and you can see there's a lot less of this fifth year age sea ice compared to 1988. Oh. And actually, I'm just going to mention here that the Arctic Ocean, as a consequence, is opening up, and one of the feedbacks happening is that with more open ocean, the water is black, essentially, and so it absorbs a lot more radiation than ice, which is white, which reflects radiation out back to the atmosphere. So you're increasing the warming potential in the Arctic. And this has an effect on land. So with this is sea ice extent here in June, and this is midpoint of plant growing season. So basically with less sea ice extent, you get more or an earlier shift in the growing season. And this figure here on the right shows 2002 to 2012. Basically, an increased shrub abundance is associated with sea ice extent. So as there's more sea ice, there's less of the birch populations, and when the sea ice decreases and warming occurs, more of these shrubs are able to invade the Arctic. Now, one of these the consequences of having more shrubs in the Arctic is they're productive, so they're taking up more CO2, but they're also darker. So there's not, much of the Arctic is a polar desert, so there's not that much snow that falls in the Arctic. And in the wintertime, these shrubs are exposed. They're above the snowpack, and so those are also darker, so you have another feedback there. I guess I can do it with this thing. So here this shows us, this is a summer warmth index, so with a 50% decrease in sea ice, it becomes this much warmer in the Arctic. And on the right here, this is NDVI, which is a remote sensing index from satellites. And basically, it's the greenness of the Arctic, so how much increase in photosynthesis is occurring. And you can see that with an open ocean, there's a lot more photosynthesis occurring. So this is potentially a good thing. As I said, there's more uptake of CO2 by these very productive Arctic plants. However, this warming has negative impacts on permafrost, and there's a lot of carbon stored in permafrost. So this is a map, a polar view of permafrost extent in the Arctic. The dark purple is continuous permafrost, meaning it's everywhere you go, there's permafrost. And as it gets lighter, there's less continuous permafrost. And there's 1,700 petagrams of carbon stored in permafrost soils, which is twice the amount that's currently found in the atmosphere. And on the right here, so I'm a paleoclimatologist, so I'm going to be talking about the past a lot as a potential indicator of the future, or what we're in store for. So this here is the last 500,000 years, and these zigzagged lines indicate going in and out of glacial and interglacial cycles. So 0 is here on this side, and 500,000 is on this side. And basically, when it's warmer, you have more methane in the atmosphere, and when it's colder during the glacials, there's less methane in the atmosphere. And what this study showed is they went into some Arctic caves in Siberia, and they basically found that stalactites, these things that scientists like to call speleothems, were not forming for 400,000 years, but in the last few years, they started forming again. So basically, these stalactites form when water drips through the ground and the minerals deposit onto the stalactite. And you need melting for that. And these scientists found that there hasn't been that kind of melting for the last 400,000 years, and now there is again. So this slide shows, again, permafrost extent here, and there's a transect of boreholes going through Alaska. And on the right here, each of these boreholes is associated with a temperature. So on the x-axis is time, so 1976 to 2012 here, and you can see that not only is permafrost extent declining, but the permafrost temperature is increasing. So the closer you get the permafrost to zero, the more likely it is that it's going to disappear. And just to show some examples of what this kind of permafrost thaw looks like, here's a thermokarst lake in Siberia, and no summertime picture in Siberia would be complete without lots of mosquitoes. This is the former landscape surface before the permafrost thawed, and because the ground is so ice-rich, when it thaws, it forms this lake and the ground subsides significantly. You can sort of see here the aerial image of this landscape. It's just dotted with these thermokarst lakes. And as these lakes form, the sediments in the soil in the bottom of the lakes release a lot of methane through microbial decomposition. Similarly, these are less ice-rich settings, so you have these boreal black spruce forests that are now inundated when the permafrost thaws, and the trees can't sustain themselves because the roots get too wet, so they form these bogs, collapse-scar bogs. So this is an example of what the surface looks like from above. And it's also a very large, because it's an anaerobic setting, it's a very large methane source. Just some more examples. This is a giant ice wedge that's thawing on the northern Seward Peninsula, the Bering Land Bridge National Park. So these, I don't have a person in here for scale, but these shrubs are probably about 10 to 12 feet high, so this gives you an example, or you can kind of sense how big that is. This is from Siberia, a massive ice wedge that formed within the last 40,000 years, is now thawing and leaving behind these giant heaps of sediment that is now, all the carbon in these sediments is then being decomposed by microbes and being released into the atmosphere as CO2. And this is as close as you're going to get to a methane bomb here in my talk. This is on an Arctic lake in Alaska. The methane bubbles get incorporated into the ice over the winter time, and if you stab them or puncture them and light them on fire, you can get these bombs. So there's been a lot of talk in the media about methane bombs and how much we should be worrying about them, particularly this study that came out in March of 2010 showing that there's lots of methane coming out of the sediments from the East Siberian Shelf area. And this was, these are presumed to be from methane hydrates that are found deep in the ocean and on the shelf. So I'll talk about that, but I'm mostly going to start by talking about the role of these Arctic wetlands and Arctic thermokarst lakes in methane production in the atmosphere, and then I'll finally talk about the hydrates. So just to give you an idea of what the sources are of methane in the atmosphere. So the natural sources are wetlands. Those are by far the biggest source. And then termites to a lesser degree, biomass burning. The ocean releases some methane, and the hydrates. And then, of course, anthropogenic sources are rice agriculture, ruminant animals like cows, energy generation, and landfills also produce a lot of methane. And this is called the flying carpet figure. So year is on the x-axis, latitude is on the y-axis, and methane concentration is on the z-axis. So basically, you see there's an interannual variation in methane concentration, and also that methane concentrations are much higher in the northern hemisphere, especially the northern high latitudes, than anywhere else, suggesting that that's where the biggest source of methane is found. Some estimates of northern high latitude emissions, so 16 to 65 teragrams of methane per year are coming out of these wetlands. Thermokarst lakes produce 15 to 30 teragrams per year. And then permafrost hydrates, initially it was thought only 5, but they've been revised upwards to 5 to 10 teragrams per year. This is a methane hydrate. And And you can see there's a pretty big range in a lot of these values, and that's because methane is incredibly difficult to measure because it escapes the ground through diffusion, but it also escapes through these catastrophic like ebullition events, and so those are really hard to document and find, and you can't like put little methane traps all over the whole land surface of the Arctic. So this is atmospheric methane concentrations in the atmosphere from 1983 to 2010. You can see there's this zigzag interannual pattern. That's because wetlands are the largest source, and so they're not producing in the wintertime for the most part, and then in the summertime they're producing a lot of methane. And this has been increasing, as you all know. And so going back a little bit farther in time, this is the last, 400 years or something. These data, the darker ones, are from ice core data. So basically, you take an ice core and the bubbles that are trapped in the ice represent the year in which that methane bubble or ice closed up. So you get a pretty good estimate of what the methane concentrations were back through time. You can do this with CO2 and other gases as well. But you can see that it was just kind of steadily increasing until about 1900 or 1950, and then it really started dramatically rising toward present. This is, again, going back 400,000 years. This is from the Vostok ice core in Antarctica. Methane is in green, CO2 is in blue. A temperature proxy is in red, and below that you have the solar cycle and oxygen isotopes. But you can see just going in and out of glacial cycles, you get an increase in methane and a decrease during the during the glacial cycles when more of the land is covered by an ice sheet. So one of the reasons we think that these boreal or Arctic wetlands are one of the largest sources of atmospheric methane is that this 2006 study from Science showed that there was a huge increase in the appearance of new peatlands. So basically what we do is we take the basal age of the peat, which is done by radiocarbon dating, and sort of make this histogram of the frequency of dates through time. So this is 0 again, this is 18,000 years ago. The end of the last glacial maximum. This is the methane curve from the GISP-2 ice core in Greenland. And you get this burst of methane during the Bowling-Allerud period, and then this is called the Younger Dryas cold snap here, which I won't get into right now. And then the early Holocene warming here. The other thing to note here, this curve here, the smooth curve, is solar insolation. So basically, 10,000 years ago, solar insolation was a lot more in the Arctic than it is today. And this is because you can think of the Earth as like a dreidel that's spinning, but also sort of wobbling on its surface. So as it's wobbling, it wobbles more toward the sun and away from the sun in the high latitudes. So this insolation curve actually looks a lot different depending on where you are latitudinally. But in this case, we're looking at the Arctic, so this was actually a much warmer period for a lot of the Arctic. So we can potentially use this as a guide to what may happen in our future. Zooming into a study from Alaska, you see the same, it's kind of hard to see on this, but there's a red curve here that basically shows the same increase in peatlands starting in the Bowling-Allerud and going into the early Holocene. And the reason these peatlands were able to start forming earlier in Alaska is because maybe counterintuitively Alaska was not glaciated during the last glacial maximum, and this is because it was too dry there to form an ice sheet. Similarly with thermokarst lakes, so this is a similar plot. This is the Greenland ice core methane curve. You can see that the frequency of basal ages from thermokarst lakes also increases during this warm early Holocene period and also a little bit in this warm Bowling-Allerud period. These are just some pictures of the bubbles that form in Arctic lake ice. And if there's enough ebullition coming out of these lakes, They don't freeze over all the way. They stay open and boil like this all winter long. So methane hydrates are thought to be one of the other potential sources of methane in the Arctic. And basically what a methane hydrate is it's a methane molecule that's surrounded by a water molecule that's frozen. And they form when there's enough pressure and the temperature is right. And so they're mostly found under 575 meters of ocean. And you can also get stable gas hydrates under really thick permafrost. So I think below 220 meters, they can be stable. So you can imagine that if this really thick terrestrial permafrost thawed, you could get a release of this methane hydrate into the atmosphere. Similarly, you could get a methane hydrate release from the ocean. And this became a hot topic because, as I said, from that 2010 paper, it was measured coming out of the eastern Siberian shelf area. And they thought that this was a potentially new source. But whether it was a new source or whether it was just newly measured is a question which I will address. But I'm going to go ahead and say that I don't think that this is going to be a methane bomb that's going to catastrophically release. And one of the reasons for that is that there is methane percolating up through the ocean, but it also gets consumed by another microbial community called methanotrophs. And so very little of this methane seeping out of the ocean is going to actually make it to the surface of the ocean. So one other way we can look at whether or not methane hydrates were one of the sources during that warm early Holocene period is we can look at the isotopes of the carbon and the hydrogen in methane. So this is just a plot of the hydrogen. Deuterium is what the other isotope of hydrogen is called, and then C13 of carbon on this axis. And you can see all of the sort of more geologic sources, coal, gas, and gas hydrates occupy the space down here, whereas all of the more biological processes, boreal wetlands, ruminants, tropical wetlands, living plants, and biomass burning are up here. And this is just showing the same deuterium values with the different types of sources. And again, there's enough of a difference in their isotopic value that you should be able to tease that out when looking at the ice core records. So this is the ice core record from Greenland, and here on the top you have the delta C13 of methane. This is the methane concentration curve. Here you have the deuterium concentration curve. And this is just the oxygen O18 and of two different ice cores. But basically, just quickly, I'm going to say that the direction of the shift in both cases is not the right direction in order to get methane from these gas hydrates. So I think it's a very unlikely that they caused a lot of the methane emissions at the end of the last glacial maximum. And I also think that it's unlikely, therefore, that we're going to see that kind of bomb escaping in the future. So conclusions, there's accelerated warming in the Arctic and its ability to store carbon. Some of the main feedbacks are a decrease in sea ice, shorter snow cover season. Both of these create a darker land surface, so you have more heat absorption, and therefore this feedback in warming. These warmer permafrost temperatures are going to result in a greater release of soil carbon from thawing permafrost, dramatic ecosystem change, and leading to shorter snow cover, etc. The release of carbon, however, is not necessarily from catastrophic methane hydrate release. But I think one thing we do need to worry about is the terrestrial permafrost thaw, because it's a very large source, and the mixing time of methane in the atmosphere is very short, and so this is going to affect all of us from a radiative standpoint. And that's it. Thank you.
Well, I'd like to thank all the speakers, and we're going to come back up here now and take your questions on all three of the talks or other topics as interest you. Okay, do we have microphones ready for the... So, yes, if you would, in asking your question, identify yourself and then ask a question. So, question down in front here.
Good afternoon. Thank you for being here and sharing all this. I'm Dr. Sam Hancock of Emerald Planet and Emerald Planet TV. But looking at all the changes, we were talking about many of the negatives that are occurring up there. But like Igor, the impact on the native communities and the more modern communities have developed there. What can be done as far as utilizing some of this change for positive for these traditional communities? And then, David, the work that you're doing as far as the Navy is concerned, what do we see as far as the positive benefits, both from shipping, mining, other exploration, as well as trying to avoid any kind of international conflict within those areas? And thank you for being here today. Thank you, Paul.
I'll let you go first.
Okay. Well, knowledge is power. So the more we know, the better we are prepared, and the better we can assess various options. So that would be probably the basic message. If we ignore or disregard what native people see and tell us about what's happening in the Arctic, we're just going to have weaker understanding, less resources, and a very skewed vision, that I would say. It is still much work to be done. It's despite 20 years of collaboration, it's still very much work in progress. How we can not only learn how to read indigenous records, but how we can learn to use them. I think we're making progress, but this is where we stand now. Hardly any perspective from indigenous knowledge so far, to my knowledge, has made it to the practical plans implemented by agencies or governmental or state institutions in Alaska or in the Arctic, which I believe is a very sad kind of status. I cannot say more except that we keep working on this. We will keep bringing indigenous people more to the table, and I hope that eventually we will develop this understanding. It's not like it has to be done tomorrow or it will be late. And they keep saying we are strong. We lived in this place for thousands of years. It's happening for 3 decades now, and we so far adapted to this more or less, and we could adapt perhaps, and with help we could adapt even more.
For the security aspects of this, there certainly can be opportunities. If you take a look at shipping, and it's a real open question. I think most of the shipping community believes it's sort of point-to-point and commodities like bulk iron, those sorts of things, will probably use that shorter route. The container industry is basically one based on reliability, not necessarily speed, but if I'm going to get that container of stuff from Yokohama to Hamburg and I say it's going to be there Wednesday, Wednesday means Wednesday means Wednesday. So it doesn't mean, hey, I'm going to drive to the date line, look left, and if I don't see much ice, yeah, I'll go that way. Otherwise, we'll keep on through the Panama Canal. So when you talk to folks in the major container industry, they're not that liquored up about the Arctic. They're like, yeah, maybe, but, not so sure. So that's one side of the bet. The other side of the bet is I look at what China, Korea, Singapore, Finland are investing. They're taking millions of dollars primarily private, not all, but a lot of private money, and they're trying to look at innovative ways to move containers across the Arctic. So I had that picture up. And it could be, a vessel that does not require Coast Guard support or icebreaker support that would get itself through first-year ice at an economical rate, at a reliable rate. And you can imagine, it's not too hard to think of like one terminal at basically Dutch Harbor, which is a deep water port. And I'll tell you, the premier of Iceland is very actively being suited. He likes playing the part of the suited. So he's listening to offers of building a container port in Iceland. And then the Faroe Islands say, no, you should come here because we don't have volcanoes. And it's like, okay. So do you sort of have a connector service, if you will? Is that economical? I'm not in the shipping industry, and I've heard people far smarter than me on both sides. So we'll see. It's kind of a wild card. Other opportunities. I would be remiss if I did not mention the UN Convention on the Law of the Sea. It's an opportunity. It doesn't mean that we will take the opportunity, but it is one. If you sort of do a time series of the, let's say, Department of Defense and some of the federal agencies' rhetoric on UNCLOS, you'll see in the last 4, 5, 6 years, by the way, the Arctic is really important, and this is yet another reason, because you probably remember, I've been on some of these panels, the Arctic is the Wild West, and we're going to have conflicts, we're going to have this, and it's like, no, we're not. And the reason we don't is we have the UN Convention on the Law of the Sea. Okay, pop quiz. What do Libya, North Korea, Iran, Iraq, Syria, and the United States all have in common? We're the ones who haven't assessed the treaty. So that's the kind of company that we're keeping right now on this. Just thought I'd point that out. But we do abide by the law and the spirit. Of course, the irony of the Law of the Sea, it was written by U.S. maritime lawyers to, in fact, encode and protect American interests. Hollywood, if you wrote a script of this, Hollywood wouldn't buy it because nobody would believe it. But it is an opportunity if we can use the politics from the factual, zero-based, substantive arguments. It's a great opportunity. Resources. I'll stop here, but look at fishing. We have the opportunity to get it right, rather than let's fish every species out to almost extinction or to a significantly endangered level, and then do heroic things to try to recover the species. We have the opportunity to manage this to start with. So there are some opportunities. I would say it's managing those changes. And if the changes happen faster than we can manage them, then they sort of become negative. Okay, thanks.
Down in the front here.
Yeah, Ed Barry with the Sustainable World Initiative. Just a quick question about methane hydrates as a energy source. I was in Japan and I noticed there was a lot of talk about them exploring for methane hydrates in the deep oceans as well as the Arctic. And I'm wondering if you'd comment on that as a potential source of energy, but also do we have any contingency plans for situations like deep drilling mishaps, that sort of thing? Thank you.
Well, this is not exactly my area of expertise, but I think a couple years ago, Shell Oil was on its way to drilling one of these deep platforms in the Arctic Ocean, but they got sidelined by some, I don't know if it was policy issues or what, but there was also the sea ice issue, and one of the major routes of polar bear movement in the winter time was directly where they were going to put this well in, so there was some complications. So they're definitely thinking about it, and I'm not sure that they're taking adequate precautions with potentially negative impacts of the drilling. I will also say that one of my colleagues at the University of Alaska, who is studying the potential for using the methane coming out of thermokarst lakes as a methane source or as an energy source, she tried it and it didn't seem like it was going to be economically viable because it's so hard to know where exactly these ebullition events are going to occur within the lake, and so it's hard to harness that as a source.
all the way in the back.
Thank you. Ray Arnado, formerly State Department, now with AAAS. Quick question, a simple answer really. Do you have a 30-second or 60-second elevator speech when you sit down on an airplane next to a guy who says, I don't believe this stuff? I mean, none of it. It's not true. Given that, roughly what, 40, 50% of the country doesn't, and one of our major political parties doesn't, and journals like Wall Street Journal are saying nonsense. I have one, but you guys are the experts. What do you say when someone says, do you really believe in climate change? And, like I said, 60 seconds, just what do you hit them with first, or how do you convince them?
I'll take a stab, because I'm sure we've all been asked this. You get this. I say, well, just it's pretty simple. You can look at a whole lot of independent, different lines of evidence. If you don't believe the air temperature data, you think it's a massive conspiracy, then look at the ocean data. If you don't believe that, look at what the ecosystems are doing. If you don't believe that, look at how the ice is melting. Now, if you think it's a conspiracy, remember, this is a government that can't even run a website. So if you think that somehow our government has been able to harness scientists who have, there would be a Nobel Prize if you could overturn the theory of global warming and get it published, and it turns out it would be true, because a lot of the people who don't believe this think, well, I'm Galileo and all you guys are troglodytes. It's like, well, actually there's every incentive in the scientific community to find a reason why this is wrong. There is a Nobel Prize. You will have universities named after you. But nobody's been able to do that. Now, if you think our government is suppressing that, again, we're the government that can't run a website. So do you really think that, we're smart enough? I mean, I worked in the government for 35 years, I can tell people. We're not smart enough to be able to do that. We can't suppress information. I mean, look at what Snowden's done. Look at what that WikiLeaks guy or girl or whatever he is has done. I've signed away papers. I've signed all kinds of things. I've taken lie detector tests. I mean, the government works really hard to try to keep information. Nobody's doing that with this. So that's the conspiracy thing's really easy to answer. You can. It's pretty simple. Independent lines of data. I can show people that. And as I said, and if you don't believe that, I go down to goes intos and goes outos. If you have more heat coming in than going out, I'll just take a balloon. If you put more water in than's coming out, what happens to the balloon? And I've had this in a bar in State College. It's like, but the Chinese are taking our job. It's like, don't worry about the Chinese. What happens? More comes in than goes out. It gets bigger. Okay, now we're getting someplace, and you sort of get it down to the cutting edge 19th century science of, greenhouse gas and radiative transfer equation. So you can do that if you're still talking to them or if they haven't stopped. I've got a picture of Jim Hansen's, some of his early models. They were published in Nature in May of 1980. Turns out they were pretty darn good. They were actually a little conservative. The Earth's warmed up a little bit more. So if you want to talk about computers, it's like, actually, they're not all that terrible. But you don't even have to get there. It's like, just look at the data. And then it's like, well, it's natural causes. It's like, well, tell me what those are. Just tell me what those are. That's always good for an interesting time. Okay, I'll let others take a whack at that.
Well, I never had a chance for an elevator speech to someone who doesn't trust science, but I probably could say that if you don't trust science, I've worked for 25 years with people who live in the Arctic. And they see, as I said, their environment changing 24/7. And what is, to me, most compelling is that across the Arctic, people like myself, doing similar kind of work, they come up with the very same data. So even if scientists do conspiracy, I can tell you indigenous people do not across the Arctic. So if they are coming with compelling arguments that their land and water is changing, it's not cold enough. They don't speak about warming. It's not cold enough. So yeah, I trust them.
I guess what I usually tell people is that in the history of climate history as we know it, this kind of warming has been unprecedented, and there's no other explanation for it besides what we as humans are doing to the Earth. And, you know, there's always those climate deniers who talk about like, oh, well, isn't, you know, these cycles have happened before, isn't this just one of those cycles? Well, actually, based on those cycles, we should actually be heading toward an ice age at this point. So if you put all the orbital parameters together, there's no reason why we should be on this like catastrophic warming scenario at the moment.
Down in the front here.
Well, Jay Shukla from George Mason University. First of all, if I can just make a comment about this question. Obviously, it has been answered very well, but I think the thing to repeat is that there is absolutely no scientific study which can produce this global warming without the greenhouse gases, no matter what you do. But you still have a good question. Why 40% of the people don't believe it? That's a good question. There, of course, we have different answers. My answer is that there is such a well-funded, well-orchestrated campaign to confuse people. You have to read books like Merchants of Doubt. You have to book who are just constantly trying to create confusion. And that is, I think, one of the reasons. But that's not the reason I actually raised my hand. The reason I raised my hand is that, in a way, it is relevant to the question. Any discussion about climate change has to talk about uncertainty. There has to be some discussion about uncertainty. Almost all three of you showed the Arctic temperature, 60 to 90 north, constantly going up, okay, all the way, very happily going up. Well, if you had put on the same curve the global mean temperature, you'll see that, well, for the last 15 years or so, the global mean temperature really kind of flat out. The reason I'm saying, so you get a divergence between the global mean temperature and the Arctic temperature. And the reason I'm pointing out is because, so therefore there are two different opinions. And these are genuinely different opinions among the sort of the scientific community, is that either Arctic trend is the actual climate change and global will catch up with it sooner or later. And in a way, this hiatus will go away and we'll have come back with a vengeance, a big warming, or that the global mean hiatus is really for genuine reasons, and it's just the Arctic is not being influenced by it. And therefore, this current acceleration of global warming is really not human-induced, but that could have because of several natural variability factors. So having these 2 points of view, I would like to put you on the spot. If you want to share, I can start with Dr. Jones. Where do you stand?
Where I stand on whether or not there's currently global warming?
No,
or
the Arctic is a natural variability.
Okay. So you're saying the Arctic is not part of the anthropogenically caused, the warming in the Arctic today is not part of the anthropogenically caused warming?
The acceleration of the Arctic, which is much higher than
Right.
the global
Yeah.
that
Well,
component.
I think especially if you look at this particular winter, and we all are familiar now with the term polar vortex, the excursion in the jet stream that was bringing all this cold air down south was actually bringing a lot warmer temperatures up north. And I think that there is natural variability in these weather patterns. Like, for example, I think in Denali National Park in January, they had a temperature of 61 degrees Fahrenheit, which is unprecedented. You know, normally it doesn't get above minus 25 degrees there in the wintertime. Believe me, I lived there for a couple years. But so I think there is this natural variability that occurs that's overprinted over this long-term signal of warming that's happening. So sure, we may be not warming as fast during certain periods as other periods, but if you look at the long-term trend, especially if you start going into the paleo record, there's no doubt that there's a long-term warming trend, both globally and in the Arctic.
I hope you will appreciate the wisdom and the beauty of putting the three of us at this podium, because we will speak with very different voices. So I will share with you my experience of being at the meeting organized by the IPCC team on indigenous knowledge of climate change. And I worked in the Arctic mostly exclusively on this very topic. But I was sitting for 3 days with people who work in South America, in Africa, in Southeast Asia, in India, and many other places. And what was remarkable is that nobody said that life is being as it always was, like something as usual. Everybody was speaking about some dramatic changes. Perhaps we were self-selected, but nonetheless, it was warming in the Arctic, it was droughts all over the tropical areas, it was melting of glaciers in the mountainous areas, it was unpredictability, and people were sharing the stories that were very different in specific physical parameters of what's happening, but they were all about the same that we have been observing in the Arctic already for 2 decades. Increased unpredictability, increased volatility of what's happening. The traditional patterns of predictions of adaptation are not working anymore. And people from the mountainous areas, and also small islands with their rising oceans, these people and people who do studies of small islands, they keep saying, well, you are in the Arctic, you're probably way ahead of us in what you know, but also in the Arctic it may get a little bit warmer, so what? In small islands, if it's get a little bit higher, we won't be there anymore. So there are, even if the Arctic is changing 3 times or whatever, twice faster than other places on the globe, there are some other places on the globe where fellow citizens are at higher risks than we have in the Arctic.
Yeah, I mean, if you sort of gave, hypothesis A and hypothesis B, where A is the rest of the world's going to catch up and the so-called pause or whatever is probably going to end at some point here sooner than later. I mean, that's where I would be. I mean, and it really comes down to kind of, what I look at as basic physics is we haven't stopped the forcing function. Mm-hmm. The forcing function is greenhouse gases. It's, as I mentioned, cutting edge 19th century science as to how that works. And we keep increasing the forcing function. Many of the numerical models, in fact, do show that you can easily get 5, 10, 15 years in which a temperature, a surface air temperature, looks like it's kind of constant. And then you get a big jump. So I think, in the next 5 or 6, 7 years, stand by. It makes sense, and Miriam nicely went through all the Arctic amplification, the change in the albedo, and it's changing in the summertime when you do have the solar insolation, not in the wintertime so much, so when it's dark, so it doesn't really matter what the albedo is as much. So, I mean, that all makes sense. What Igor talks about, I think, if for any of the engineers or physical science people in the audience, I mean, what Igor's describing is how you would experience a non-stationary time series. All of a sudden, what you knew from your oral history and from the wisdom of your, generations past, which worked, doesn't work anymore. That's a non-stationary time series. So, I mean, that's just another line of independent evidence for all the conspiracy people as to why things are changing. I'll stop there. Thanks.
And I'm going to jump in here and add, there's another thing about natural variability and climate change. We hear about, the polar vortex and these extreme events, and we hear a lot about the severe drought. And there's an important distinction to make, and that is, are we able to say that these things are consistent with our understanding of the climate system if it's going through a climate change? Scientists are pretty comfortable making those kind of statements. They get transformed into, they prove climate change. And I think we have a lot that we don't know about the nature of these smaller vortex, the polar vortex, these shorter term climate changes. Well, they are climate changes. They're changes in what we experience as the average of the weather for this winter. But these higher frequency changes, they can certainly be consistent with having a long-term climate change, but you may not be able to actually identify that for many, many years.
Could I just make a very quick comment on Paul's great point there? I mentioned kind of in passing, and I think we have at least one gentleman from American Association for Advancement of Science, maybe more are here. If you have not seen the What We Know, it just came out yesterday. I really recommend looking at that. It was written in plain English, so whoever did the editing, congratulations. I don't know if it was Marcia or whomever, but somebody wrote it in English. That's always good. The other thing that I really like about it is it really sticks to the components of climate change that science is very, very comfortable with. It does not get into tornadoes. It does not get into hurricanes. It does not get into snowstorm X was climate change, which are frankly much, much, much more tenuous and unproven links. And then people who want to delay this conversation kind of jump down that. So that's good. When I'm asked, this is my another elevator speech, difference between weather and climate, if anybody's played like poker. Now, when I gave this talk in Utah, I had to say, get on a bus, drive to the Nevada state line, and then we can talk about poker, and they got that. Imagine, some of these, big droughts or whatever, like getting a hand of full house with aces high. That's your weather. Weather is the card deck, or the hands that you're playing. Climate is the card deck. And I would argue that we're probably putting an extra ace or two into the deck, and that's climate change. So that's kind of how you can think about this. Climate is the card deck. Weather is the hand that you were dealt this moment. And, if you've played cards, sometimes you get great hands for a while, sometimes you get lousy hands. But ultimately, the kind of hands you get depend on what are the cards in that card deck.
So you don't play dice with Jim Hansen, I guess.
I couldn't afford to.
Okay, more questions?
Well, there's
Down
one.
in the front here.
Thanks. My name is Lindsay Tam from the Climate Protection Campaign, and first, I just really appreciate this panel. It's really interesting to have so many different sectors about the Arctic represented. Mr. Krupnik, I was really interested and agree with your comment about Native communities in the North as thinking about them as fellow citizens at risk. And, I think that this view is really unrepresented, and nobody's really championing that view and that relationship. And I'm just curious, what's your kind of ideal strategy or scenarios or ways to engage that understanding for people, down in the lower 48 or just around the world? Like, how do we engage people in the North that are dealing with sort of the impacts of climate that is going to be a reality for people in the San Francisco Bay Area, where I'm from? What would you do?
Well, it has been already said here that we are dealing with very powerful forces, not of ignorance, but of ignoring. And it has been a consensus in climate science for at least 10 years that it's happening. I was surprised to learn from my indigenous partners that they knew about changes in the environment sometime like at least 5-6 years prior. And they often said, well, Igor, stop asking us about climate. It started in 1995 or 96. And how do you know? And then there was a long story of how did they know that in 95 or 96 something happened to their environment. So you put it in the books or you put it in public presentations. You keep telling it to other people and they listen. And this is happening somewhere very far away. Somewhere a polar bears on the chunks of ice. And this is not what is important. And every time I've been asked about what is your, not only your elevator speech, but what would you tell a farmer from Nebraska or, someone in rural Pennsylvania about climate change and the Arctic? And it's really hard to say something until the message is brought home. So, unfortunately, The only way people stop ignoring the signal will be when the signal comes at your doorstep, unfortunately. And we all kind of had this impression that the Hurricane Sandy was the watershed. That after this, we all start thinking what would happen to downtown Washington, D.C., the floodgates that should be built on the mall. I've seen these maps, what would happen to us, and how the basement of our Smithsonian buildings will be flooded with the ocean level rise just a little bit, or another major storm. And I think, unfortunately, again, there are many factors at play, and not necessarily the foul play, and not necessarily the conspiracy theories. It's just maybe that our mind is working that way. That if it's happening 5,000 miles away, 8 or 4 time zones away, it's not about us. It's about those people, those strange people in fur clothing, hunting whales or eating walrus. It's not about me. But when it comes to my door, maybe then I'll start thinking. So unfortunately, I don't have a recipe. Just keep talking. Just keep telling people what is happening with your fellow citizens. Again, you're right. You have to put this very important pair of words in your speech so that then it becomes closer to your heart and mind.
Yeah, just sort of add something to this, because I think it was the last slide I showed. I said it's all about leadership. Mm-hmm. Leadership really does count. I mean, the Department of Defense and the Navy, just by themselves as bureaucratic organisms, bureaucrats are like people. They don't like conflict. They're not going to go and poke the bear of the Republican House on this. But there were leaders there who said, no, this is important because the environment's changing. We got to deal with it. Without leadership, this will be very, very hard. If I can be just a little provocative for a moment, I have asked in people who do climate communications, I said, an interesting study might be to look at how the gay community went from, in 10 years, it was a fringe issue that doesn't affect me, and why should I care about their rights or their marriage or whatever, to having almost flipped. To an awful lot of people now say, well, geez, of course, they're humans, they're just like us, of course they should have rights, and why wouldn't we ever have something else? And it's, I don't know what the demographics are, 6, 7, 8, 9, 10%, something like that. It's not a whole lot of people, but it flipped. So how do we get the Arctic, which isn't a whole lot of people, mm-hmm. Is it popular media? What is it that would do that? And it may not even be the right analogy, but that's as close as I can come to something which had been kind of this niche issue over on the side. A lot of people said, nah, there's no political gain for me to support this. And it changed. So how do we have that kind of moment with climate issues?
And it actually may not be through the Arctic. And most certainly not through the Arctic indigenous people. So I agree with David that some kind of game changer is needed, but I'm not sure that they are. We tried it for 20 years with the Arctic, and it didn't work. So maybe something else is needed.
Is it Miami going under?
Yeah.
Well, just to add to the sea level question, I think a lot of the increase in sea level is driven by the decrease in the ice sheets in Greenland and Antarctica. And if we can somehow make these highly populated locations on the eastern seaboard, for example, understand that this sea level rise is very real, perhaps that's a way to go about it. Definitely from wetland cores I've taken off of the coast of Georgia down to Florida. The rate of sea level rise is currently unprecedented in those, like the wetlands just can't keep up with the rise in sea level in those locations. So I guess, if we have another Hurricane Sandy, that's going to wipe out a lot of these wetlands.
One of the problems I always have is that people talk about how the climate is changing as though at some point we'll get it and then we'll just stop it.
Right.
Right? It's like, we can live with this. It isn't too bad. It's not too bad yet. a little more air conditioning. And so when it gets too bad, everybody will wake up and we'll just stop it. Well, and that was, I was just thinking this, the thing we left out of the Arctic is Greenland.
Yeah.
And the base of the Greenland ice sheet. It may be melting and moving. It's moving. The glaciers are moving at an incredible speed now. And if we were to stop all emissions of CO2 right now, I'm not sure that a lot of Greenland doesn't just keep on going.
I think,
And
yeah,
you know that. So we're causing all sorts of problems that are also going to be coming back. We can't just say, okay, this is enough. Let's stop.
Yeah, we've already baked in 4 to 7 feet of sea level rise, long term. Oh, that'll take centuries, but already at least 4 to 7 feet. And if you really want the wild card on the ice sheets, look at Antarctica, because at least Greenland gets funneled into fjords, which is sort of like a 2-lane road. It's sort of like me driving down I-270 at the wrong time of day. But the Antarctic is like a 12-lane freeway. And if that gets going on some of those West Antarctic ice sheets, stand by.
And people are worried about the East Antarctic ice sheet not being as stable as we thought it was. But
So it's stand by.
Well, the other thing, I guess, now is also people are talking about geoengineering to try to bury some of this carbon out of the atmosphere as a potential way to sort of mitigate the warming. But I don't really know what the feasibility of that is. And at this
Paid
point.
announcement, the National Academies has a committee on that. Marcia McNutt, who some of you may know is the chairperson. And our report, I'm on that committee, our report will be out probably late summer. So that'll, no controversy there. So
down in front again.
I'm a double dipper. I don't hope you don't mind. I'm Sam Hancock of Emerald Planet. But going to Igor, we've been doing a lot of work over the last dozen years out in the South Pacific, in Micronesia, the Marshall Islands, the Solomons. And so we're seeing sea level rise, you know, the death of the coral reefs, and, you know, all this is happening at a very dramatic rate. But what can we learn, to give you a platform, what can we learn from the indigenous peoples, you know, in the Arctic zone that we can incorporate or, you know, start thinking about that's impacting? Because, again, we're in Washington, D.C., which is only 3 feet above sea level, like many of these islands in the South Pacific. So sea level rise can be alive and well to us in a very quick time period. Thank you.
I'm delighted to answer this question. Yeah, literally. Yeah, thank you. I've been asked many times, by the way, and people from the tropical areas are extremely interested in how we do this research in the Arctic with indigenous communities. And first of all, they kind of look at us as a model on how you should collaborate as partners, because we have done it now for almost 20 years. We have developed certain ways on how we listen to them, record indigenous knowledge, how we put them as partners, co-authors, how sensitive and attentive we are. There is no, or at least not these days, there is no more this kind of top-down, scientists know better approach that is, to my very limited knowledge, is still prevalent in the Pacific, in the tropical areas. There should be understanding that these are different types of knowing, not of knowledge, but of knowing. There are different types of predictions. There are different types of recording things, which, at least from my perspective of an anthropologist, you don't judge which one is right if they disagree. You have to give full credit to indigenous knowledge, not to consider it like an exotic or some sort of knowledge, anecdotal evidence that, again, we scientists know better. You have to consider that indigenous observers are always right until proven wrong. And that's very different. They don't have to prove to you what they're seeing or what they're viewing. There are cases that we learned are of most interest. That is where our science data disagree with what indigenous people say. This is where we should look, not where we agree, because we know where we agree. You know, we know the basic principles. But look at those cases where you disagree, and try to find where you don't understand what indigenous people are viewing and telling you, rather than vice versa, that you know better, you have better data, you have better instruments than them. And I think that would bring you closer to the level where we are now with regard to our work with Arctic indigenous people. So I hope this helps.
In the middle and the back.
Hi. One thing that struck me about this event was that it was co-sponsored by the Brazil Institute. And I'm wondering if that's reflective of any equities that Brazil has in Arctic issues, and if so, what they are.
Not to my knowledge.
I guess the sponsors would be the ones to answer that. I think, I don't know what Brazil has. I do not think they applied for observer status at the Arctic Council.
No.
But, but don't laugh. Singapore is. Singapore is an observer of the Arctic Council. Singapore actually has a pretty active Arctic research program and policy program. I tell that to people who can't get a job in the U.S. because the U.S. doesn't realize they're an Arctic nation. Go to Singapore and you'll get a job. So India, again, I go back to a visit that the Prime Minister of Iceland had, I think, 9 months ago to Washington. And he tells stories of when he goes almost anywhere, India, China, Singapore, Indonesia, the very first question is the Arctic and trade routes and how that's going to impact things. When he comes to Washington, nobody really cares. So Brazil's obviously developing economy. They certainly do ship things worldwide, so they would probably have some interest in a direct shipping sense. As was mentioned here, the land ice, not the sea ice, but the land ice. They have a lot of low-level territory, and sea level rise with some of their big cities is going to be a huge issue for those guys, like it is for so many other hundreds of millions of people.
Well, I want to correct myself. I've heard of one scenario, I don't know, I suppose it was never on the mind of organizers, of the Brazilian aluminum ore being transported by Chinese cargo ships to Greenland to be melted there using the electricity cheap electricity developed in Greenland. So to me, this is still in the realm of fantasies, but they may come in about 5, 10, whatever years from now. What may be what may be a better reality or a better use of this connection, I think with the smart planning, we would be surprised how productive it would be to put at the same podium people who are studying climate change in Brazil with the people who are studying climate change in the Arctic. It is definitely a very different change. But as much as we learn from being with people who are studying indigenous observations of climate change, people are seeing the same unpredictability, a higher volatility, complete kind of misshape of seasons, the increase of what biologists call mismatches in the ecosystems, because animals, plants, they all kind of are attuned to a particular seasonality, which is being now dramatically changed everywhere. It's a confusion in global ecosystems, which is not necessarily through warming, but through some sort of a different signal. And perhaps having people from different environments would help us not maybe to understand that signal, but at least to recognize that it is a signal not in some exotic place elsewhere, but everywhere.
Well, I have to apologize on behalf of our host, Paulo Sotero, who was unable to join us at the introduction time, was here for a while and then had to leave, but we did from the Brazil Institute was here at this discussion, so it would have been nice to catch him on that. More questions? In the back?
Yes, my name is Jamie Carson with CC Global. Just have kind of an overview question about climate change and how to tackle it as far as it connects with communicating and really making a difference in acting now. So because climate is such a multifaceted issue, if the two of you, or if the three of you wouldn't mind giving one or two examples of where you think investment is most needed or where we can start, if the greater community is interested in jumping on board for finding a solution.
Okay, I've got 3 things because I can only remember 3. So I would do them, and probably not in this. Doesn't really matter the order. This is not a priority listing, but one is to better understand and observe the climate, because when you really start talking to the climate scientists, you find that the climate community still has a lot of challenges in attribution of specific events. And if you start thinking about this geoengineering, and if it gets bad and somebody really wants to do geoengineering, you've now added another, number of dials and switches and whistles to the computer, and you didn't already know what the original ones did. Now you're going to ask people to say what's going on. So understanding at regional scales and regional time scales. Because people, 100 years is vaguely interesting, but 10 years is really interesting, and 5 years is even more interesting. So being able to do that with greater fidelity, that's one. 2 is getting serious about adaptation. We have, somebody said, oh, well, this isn't too bad here. It's like, we've barely got on the escalator, let alone ramp the thing up to the full speed here. So we are going to have to get serious about adaptation. That is water, and it's water in all the aspects that I talked about, and particularly if you live on the coast. And then finally, we've got to figure out energy. We've got to figure out non-carbon energy in sufficient quantities for a decent standard of living for, frankly, every one of the 7 billion people on board this planet. Not just for the first world, but for everybody. And that, if you start thinking of it that way, I believe that then everybody can be invested in this, not just the first world there. So how do you do that? I don't know how you do that without having a tax on carbon or a price on carbon. I shouldn't say tax. Could be revenue neutral, could be something. But there is no incentive for anybody in private industry to do anything until there is a price on, basically taking out our waste and we dump it in the street and we don't pay for it. I mean, that's kind of what it is. When you, fly in your plane or drive your car, you're basically dumping the waste on the side of the street and you're not paying for it. I don't get away with that in State College for all my other waste. I doubt that you guys do wherever you live. So we've got to be able to change our energy structure. That's the fix. So we got to understand it. We have to apply the Band-Aid because we're bleeding now. That's the adaptation, and we have to fix it. And that's the energy part. And I don't think you do the energy part without having a price on carbon. And then let the free market go figure out smart ways. That's there. Those are what I do.
I think we probably need to make a bigger deal about the cost of climate change. So if you start looking at the economics of what the cost of, all this FEMA aid is, the cost of putting out wildfires, the cost of, rebuilding infrastructure in the north, for example, when permafrost thaws. If you add all those things up, what is the cost of that versus trying to do something real about mitigating climate change? And then, there has to be some incentive by the government or somebody to come up with a non-carbon energy source. Because right now, I think the oil and gas lobby is too strong in Washington, and there's not really a real incentive to change that.
Well, my recipe would be to put human face on climate change. And that's what I put in the title of my presentation, Fellow Citizens at Risk. It's like we tried it with polar bears, or we tried it with a lot of science data, and although we came to definite consensus within the science community, we actually got nowhere with the general public. And what David said a few minutes ago about the flip that was organized, engineered, whatever, triggered by the gay community, I believe it was done by putting human face on the problem. And I think if we can use the same metaphor, we have to engineer the same flip on our understanding of climate change not as a science problem, not as a problem that requires some sort of additional science verification. We have plenty of this, or we had plenty of this in the past 2 decades. But as a human, as a social, as a problem that we all face, not as scientists or as people assessing science data. That's something very special. That's for educated people. That's for, those white-egged scientists who operate with hockey sticks. I don't know how to do it. I know that it worked with the Arctic because we did it when we first started collaborating not only with the Arctic indigenous people, but with physical scientists who didn't trust us. Not us, who didn't trust indigenous people. They viewed it as an anecdotal evidence, that as a knowledge, cannot be verified. These are not statistical data. These are not serious arguments. And we actually made it through. And at every meeting on Arctic climate change, there is someone representing indigenous knowledge or people who work with indigenous participants. So to me, that was a very effective and successful way of turning the table. So I would say that for people in your field who are trying to do a public campaign about climate change, look for faces of climate change. There's one other thing I learned. It turned out that people in the Arctic, although experiencing maybe climate change at twice rate than everywhere else, are not the most suffering because of climate change. There are places in the United States that are much more affected, but we don't know about them. Let's say the Navajo Reservation or the the native nations that are cornered in the Southwest would be the next major victims of the droughts that are going to hit the Southwest because they have been cornered in the driest places on the worst lands that have been allocated to their reservations. So there are a lot of the conference I attended was called Indigenous People, Traditional Users and Marginalized Populations. There's a lot of marginalized populations on our planet that will be suffering from climate change much more because they're marginalized geographically, in terms of resources, in terms of education, and in terms of their voice. So this may be probably the voices of climate change until you learn how to bring the message closer to home.
Just one thing on Miriam's comment there about the money we spend. Anybody here from either Staffers on the Hill or from OMB? It's okay. You don't have to admit it if you are. And this isn't a slam. It is our system. How long did it take us to get the, 50, 60, 65 billion for Sandy? Fairly simple. Not probably quite as fast as people wanted, but it was pretty simple. Imagine trying to do that on budget, finding $65 billion in today's fiscal environment. It's like you just get laughed out of here. So the money, like for prevention, like the Forest Service, I think, goes through this, they can't get money to prevent the forest fires and to do the management, but we'll find the money to fight the fires. We don't have money to actually go and prepare communities for the next significant storm surge, but dollars to donuts. We'll then appropriate 30, 40, whatever billion dollars to go fix them, more or less as they were before. So we've got to, this is, you can't even talk about this unless you're inside the Beltway. People have no idea what you're talking about. But this whole color of money issue, whether it's on budget or off budget, we've got to come to our senses that it's still a dollar is a dollar, even though it's not looked at that way, and spend dollars smartly, because it's being shown a dollar in prevention is $3, $4, $5, $6 of prevention, but our system doesn't let us do that.
Thanks.
I was reminded that, I mean, the whole argument is you have to internalize the externalities, that in the energy business, you know, you don't pay for the costs of the damage you're doing by releasing the CO2. You just get to take in the profits from not worrying about that. And
Freedom.
that's the sort of movement that really has to be there. So.
Well, I'm kind of struck by the irony of all the oil wells that are on the North Slope of Alaska. Their season for being able to drive out their large vehicles and equipment onto the tundra is becoming shorter and shorter because the season of thaw is increasing and the permafrost itself is thawing. So it's sort of, you know, it's something they should be thinking about. I don't know if they are, but yeah. But anyway.
Okay, well, I think that kind of takes up our time here. I'd like to thank our panel again. Excellent job.
All right.
And
Thank you.
stay tuned. We'll have more of these. We have more of these scheduled this spring.
Mary, let me give you a card.
Oh, okay.